Welcome back to our next video here. And on this video, we're going to talk about custom classification and named entity extraction, which is a pretty important component in some organizations. And in here, we'll talk about how do you label documents, and then we'll talk about training and deploying the model so that way you can use it in a custom classification setting. We'll talk about, how do you understand the model performance? How do we identify that performance and determine, where do we need to improve it? And then finally, how do we connect it to our own custom application? So those are the things that we're going to cover here. So first things first, in order to create a custom text classification instance or to use the technology, you're going to have to pretty much follow the same process that you did with the other AI services, where you have to go into the Azure portal and create a Azure resource, an Azure AI resource specifically for text classification. And this is going to be part of the language AI service. Once you've created that instance, that resource in the Azure portal, then you're going to go to the Language Studio portal to do your additional manipulation, training, testing, and tweaking, if you will, if you need to modify your model at all, before you actually deploy to make it available for any of your applications to use. So it is a multi-step process, which we'll demonstrate when we go through the demonstration in the lab environment, where I'll show it to you. But just keep that in mind. So what you're seeing here essentially is one of the steps that are required to do this. And this is a critical and important step because of the fact that in order to do classification, we've got to be able to label the resources. Now, in order to do that, what you're going to need to do is you're going to need to connect your documents to Azure. So to be more specific, what you need to do is you need to create an Azure storage account, and within that Azure storage account, create a container, and within that container, load all of your documents. And once you open up the Language Studio and you start the project, which is what it's called for this, you're then going to go in and select that storage account along with that container to be the repository where all the data that you're going to classify is located. So once you've done that, which you'll see in the demonstration, the next thing that we do is we need to take, and as you can see here, we've already got some documents, some text documents that are loaded in here. These are going to come from the Azure storage account, the container. So once you have the documents or any of the data, then what you need to do is you need to define your labels, and your label classes are going to be listed over here. So you would select the option to add a class, and then in this case, they've done classified, sports, news, and entertainment as the examples here. So you're going to add the classes, and then for each document, you're going to select the document, and then you're going to select over here which class it is. And this is essentially the process of essentially tagging it, if you will, or labeling it. So once you've got all of your documents labeled, the next step in the process is to train the model. And during the model training process, what's happening is the service is using machine learning technologies to analyze the data that you've identified along with the labels to learn to determine exactly, what types of documents or data should have a certain type of label. So that's what's happening during the training process. Now, once the training process is completed, you actually get some training results, and we'll dive more into the training results here shortly. But you're going to get some training results, and in those training results, it's going to identify how well your model learned and how well it can perform in predicting the correct answer, in this case, labeling of documentation. And that'll all be demonstrated here in our lab. Once you've trained your model, then you must deploy your model. And what deploying your model essentially does is it defines a endpoint that you're going to use. It makes that model publicly available or internally available, depending on how you configure it. But it makes that model available within your application code. Now, when you're configuring this text classification project, one of the options you're going to get is, do you want to provide single label, which in this example here, if you notice, this document, because it's a radio button option, it can only be labeled with one thing at a time. Or there may be in some cases where you need to label things with multiple labels. So you do have the option to do that. But keep in mind, this is something that will be defined when you create the label project, as you'll see in our lab demonstration. Now, so that's one of the options for data labeling. Another option we have deals with custom name entity recognition. And again, there's some additional components that you'll need here. For this right here, first you need to define your documents, just like we did before. You need to define the labels that you want, the entity tags, if you will, which is step number 2. And then you go into the actual documentation, the data, and you're essentially going to create brackets. So when you click on the left side here, it starts to bracket, and then you would do a closing bracket, and then it'll give you a listing here of all the entities that are available. And this list will be based off of what you defined here. So think of these almost as tags. And the purpose of this is to help the model better identify, where data will be located in what position it will be located within your documentation. That's its primary purpose, is to help you're helping it understand, okay, based on this document here, this right here is a city. So the model's going to say, okay, this is a city, and typically that city identifier will be somewhere within, maybe this sentence or within this part of the document and so forth. So anything that you can do to add entities will further enhance the model during the training process. So once you've labeled everything, then you train the model, and that will allow the model to go in and learn based off of what you defined. It'll learn it. And then once it's learned, you can, again, just like with our previous example, you'll get a score that will identify, there's actually 3 different scores you're going to get: an F1 score, a recall, and a precision score. And those scores will help you better identify how well the model is doing. And if the score is within the threshold that you want, you can then deploy the model. If the score is not within the threshold you want, then you do have the ability to go in and maybe modify your labeling a little bit more, maybe add some more data to the data set for learning, and then retrain your model until you get the score to the threshold that you like. Now, I've been talking about this score, and here you'll see the score itself. So this will identify exactly what or how well your model has not only learned, but through its testing process, how well the tests have occurred. So there's an internal self-testing process that occurs. So let's talk a little bit about what these 3 scores are here. These 3 scores basically identify how the model is doing. So let's take a look at the first one here. We're actually going to not start here. This is actually the last one that we're going to look at here, even though it's first in our list here. We're going to look at precision and recall. So the first one that we're going to look at is precision. And basically what this means is, during the testing, so once the model has done its training, it runs some test samples through it. And during that time, it runs those samples through there, and it's determining how well the model can respond. So what precision is looking at is essentially, what's the rate of false positives? That's really what we're looking at here. Let me give you an example, kind of a very easy to understand example here on how this works. So with precision, let's assume for a second, we had a model that diagnosed that 15 patients, so patients, I'm just going to put PAT for patients. We have 15 patients here that have been identified as being positive for something, maybe a disease, high cholesterol, whatever it may be. We've got 15 patients that have been identified in the model's training process as being positive for something. Now, out of those 15 patients, there's only 12 that have a true issue. So we're going to call this true positive. So even though the model said, in our testing, we found 15 cases where the instance was positive, but in all actuality, the real number is there's only actually 12 that are positive. So when you look at this, there's 12 true positives, but there's 3 additional ones here because we have a total of 15. Those 3 additional are what we call false positive. So what this is looking at is basically, what is the rate of false positives that we're having within here? So from an accuracy perspective. So to determine this value, the percentage, this precision score, what we do is we take the actual true positive number, and we divide it by the true positive, which is in this case, and we'll put it in here, the true positive of 12 plus the false positive, which is 3. And if you do the math for this, it ends up being roughly, let's see here, about 80%. Actually, it is exactly 80%. So what this is telling me is that this model has an 80% accuracy when it comes to determining false positives. So in this case here, there's not that many false positives. So that's what your precision score is. The second score that we have here is our recall score. So using that same example. So in our example of patients and determining if they're positive of something here, what we're looking at here is what are the actual amount of patients cases that are positive. So let's say we have 20 that we know are truly positive, okay? So we're going to start with a sample set of 20. But the model, when it does its testing, only finds out of that 20 that we know is true positive, it only finds 12 true positives. So there's a difference here, which means if there's only 12 out of 20 when there should truly be 20, that means in this case, if we do the math, there are 8 false negatives, meaning there were 8 patients that were identified as not having an issue, but actually do. So the model found 12 and it missed 8 of those. So in this scenario, this is where recall comes into play. And what this looks at is it looks at the total number of true positives. So in this case here, the total number of true positives, which is 12 in this case, and we're going to divide it by the total number of true positives plus the false negatives. So we're going to divide it by 12 plus our false negatives, which is 8. And so when you look at this, it's 12 over 20. And when you do the math, when you do the addition here, that's about 60%. So the precision score looks at basically misses. You know, how many did we miss? Whereas the precision score looks at, how many did we get wrong in the sense of we overestimated versus underestimating or under predicting. So precision looks at over predictions, recall looks at under predictions, if you look at it that way. So that's what those two numbers are. And these are calculated automatically when the testing completes. Now, the last one, which I intentionally left for last, even though it's first in our list here and first in the image, is F1 score. The F1 score, it kind of helps with these two numbers here. If you think about it, I've got these two numbers here. So let's say this is 60% and this is 80%. The F1 score is an average of these two. That is what your F1 score is. So it's looking at the total average of those. So if we look at this here, and again, let's do the math for this to kind of look at it. F1 or F1 score equals the precision. So let's say our precision was 60% in our example, and our recall, actually, I think I've got that backwards here. Let's see here. Yeah, so this was 60%. This was 80%. So F1 is essentially the 80% times the 60%. So it's basically your precision times your recall divided by 80% in this case here, plus 60%. We multiply that by 2, and that equals our F1 score. So that is the formula that we use. So if you look at this, 8 times 6 is 48. So this is 400 or it's 0.48 because these are decimals actually, divided by, and then 0.8 plus 0.6 is 1.4. 0.8 plus 0.6 is 1.4. We multiply that by 2, So which ends up our F1 score being about 68%. Roughly 68%. So 68, 68 and a half, just below 70%. Or just below 69%, I should say. So your F1 score is essentially an average of your precision and recall. So if there's a number that you want to use, if you just want to kind of eyeball it, look at your F1 score. That'll give you a great idea on how well your model is doing, which you'll see in our demonstration that we'll do here shortly. All right, so with that, again, just some basic information. Let's go ahead and do a demonstration so you can actually see this in action. Okay, so let's take a look at how we can perform custom name entity recognition and so forth within here. So what we're going to do is and custom classification. So what we're going to do is there's some prerequisites that we need to do in order to do this. And one of the first things that we'll need to do is we'll need to create an Azure text classification, or more specifically, custom text classification resource. So we're going to go into our Azure's portal page here, and we're going to create in this case here, a language service. Now, typically when we create a language service, we normally will use this right here. And these are all the pre-built and built-in models that we're going to use. But for now, we're going to be using custom. So we're going to select over here a custom text classification service. And the process for deploying this is pretty straightforward. Just pick the subscription, pick your resource group. We're going to call this custom TXT SVC1. So custom text service 1. We're going to use the default pricing tier. Now, notice here, it does require that you have a storage account. So what we're going to do is we're going to use an existing storage account, and I've got one here called custom text storage account. We're going to select agree. If you need to customize, the access through networking, you need a managed identity if you want to add any metadata tags, which we do recommend all of that, then you would do that. But we're going to go ahead and just run this and validate it. Everything came back okay, so we're going to go ahead and create this. Now, the creation process takes about 30, 45 seconds here, as you can see. So we'll give it a second here. Okay, so as you can see here, the resource has been created. Now, in this scenario, I want to show you something here. So we've just created our instance here. So there it is, custom text service 1. So you see that there. Now, there is something I do want to point out. Your instance, in this case, your custom text instance will need permissions to access that storage account. Now, in my demonstration here, this has already been done because this is an existing storage account. But to show you what you would need to do is you would go in, if it's a new storage account or existing one, you would go to the storage account itself. You'll go to your access control IAM, and within your access control IAM, go to your, you're going to add a role assignment. And the role assignment that you want to add for this is blob contributor, which I already have here. So storage blob contributor. I've already got it configured here. It's in my roles, but this is something that you definitely want to consider as part of this. But now that I've gone in and I've got this configured, let's go back in here. There it is. As usual, the important things that I'll need here are going to be the keys and the endpoints, which we'll come back to this a little bit later here. But now I need to go to the Azure Language Studio portal. So I'm going to go into Language Studio. So we're going to go to language.cognitive.azure.com. Now, if this is the first time that you're connecting, it will prompt you to connect to your instance. I am already connected, but I do need to switch over to my instance right here, which is custom text service. So we're going to select that one there. And now we're ready to go. So what we're going to do now is in our Language Studio, this is where you do all the hard work. This is where you do your development in the sense of building and testing your models. And then the final product, the final model product, you can then use in your applications. So within here, we're going to create, and in this case here, we're going to create a custom, let's do a custom, in this case here, text classification. So we're going to classify data. So it's going to ask me, okay, what storage account? Notice here it already added this. Here's my AI resource instance. It already selected the storage account for me, so we can select that. We got something. Then you select next. And when you select next, you have to determine, okay, what type of labels do I want? Do I just want to tag everything with one label, or do I want to do a multi-label? So for our demonstration, we're going to do a single label tag for each resource. Select next, and then the project name. So in this case, we're going to come up with, let's call this a demo custom TXT. So demo custom text. So we'll do that. And then we have the language. So what is the primary language of the information? So for our demonstration, we're going to use English with this. Now, if you do require it to be converted or to be read by other languages, you do have the option here. You enable multilingual data set. But for our demonstration, we're just going to use English, and we're going to do custom text label. So we're just going to call it custom text label. That's cosmetic. And then it's asking for the container that holds the data. Now, in my scenario here, because I've already pre-created this, here's my storage account here. I've already pre-created the containers. So here's the container. I've got a container called articles. And in this container, I've got a bunch of different articles here. So article 1, article 2, and so forth. So this is the container that I'm going to select as part of my process here. So I'm going to go in here. I'm going to select articles, and it asks me, do I need to label this? No, I need to label my documents, or yes, the documents are already labeled. So if they're already labeled, I would then pick the labeling file, which I do have some pre-labeled files already sitting in here. But I want to demonstrate this for you. So we're going to say no in this case. We're going to select next, and we're going to create the project. All right, so now we've got, if you notice here, in my project, those articles, and there's more pages here of them, but those articles are there. Matter of fact, those match the files that you see in my storage account right here. And the reason being is because it imported those articles in here as part of the project for the training process. So now that I've got my sample files in here, the view doesn't really matter. If you do an all document view, it shows you all the files. If you do a single, it just shows you each file and then the contents of that file individually. So you can pick which way you want that to, how you want to view it. I typically I like the all documents view. It makes things easier for me. And I'll explain to you why. I'll show you why now. So now that we've got the sample data in here that we want to label, I've got to go in and actually have to label each piece. Now, remember in our presentation earlier, I said you have to add the classes. This is where you add your labels. So we're going to add some labels here. We're going to do sports. I'm going to add entertainment. Excuse my typing here. We're going to do news. You know, all the different things that we have, or maybe classifieds. Let's see here, sports, entertainment, news, classified. So we'll keep those labels. So these are all the labels that I can use. Remember, because when I built the project, I said single label. I can only label each document, each file with one label. So we'll go to the first one. So what I'm going to do is I'm going to actually click on this file, which is going to take us back to our single view. And in here it is, you know, how footballers completed one of the worst collapses in 4 minutes. You know, this is a sports related article. So I'm going to tag it as sports. Now, there's a couple of things. Number one, I'm going to label it as sports. And then down here at the bottom, I have two options. Option one says training the custom model. What this means is that it's for this file, if I select option one here, then what's going to happen is when I do my training, which is going to be a little bit further down here, when I do my training, it will actually take this file and learn from it. It'll use it for training. So we'll do the first one for training. File number 2, article number 10 here. bad news allergy, pollen. This deals with medical stuff, which is just basic news. So we're going to select news for this one, and I'm going to use this as training also. So we're going to go to, and we just go from document to document to document to do this. So this one here is entertainment. This one here is news. By the way, if you notice here, it's important that you label the data correctly, because this is what the model will use to go in and learn to train. If you mislabel your training data, then your results could be skewed as far as for what you're looking for here. So let's see, a glass L-shaped desk, that would be a classified ad. Large kennel, that's classified ad. Best Barnes new album, that's entertainment. Reality TV is entertainment. This is news. Wildfires in Kansas, that's going to be news. And then we'll do the final one here. This is an Oscar one, which is entertainment. So I've gone it through and I've labeled all my documents, but what I'm going to do is I'm going to take number 10 and I'm going to change it to testing. So it's not going to be used to train the model, but when the model does its testing, it's going to check it. So let's do 10, 11, and 12. We're going to retain those for testing purposes, which you see down here. So now that we've got everything, and let's make sure I've got them all labeled here. So we've got them all labeled here. So then you would save it, which I've just saved it. So you notice here it's saved. So now I've got the data labeled. The next thing we need to do is we need to tell the system, okay, take this data that we've labeled, whether it's the training one or the testing, and we're going to build a training job. In that training job, it's only going to look at the ones that are identified as training to use to create the model. The testing will be used for the testing purpose. So we're going to go to training jobs and we're going to start a brand new training job. Now keep in mind, this is using machine learning underneath the hood. So let's call this training job, we'll call it job 1. Now in the real world, call it something a little bit more realistic. And we want to split, so testing versus this, or I can go in and say use manual split of the training data. So I'm going to let the system do it in this case here, and we're going to train. So this takes, because there's a small data set, this is going to take a minute or two. Obviously, the more data that you have, the longer the training is going to be. But the good thing is the more data that you include as part of your training, the more accurate your model will be in its predictions, which is a very important thing. Okay, so now you see that the training has been completed. It just disappeared. You'll see that the training has completed here. So we're good to go. So now at this point, what has happened is the system has taken all of the data that we've included except for, and built a model around that, used that to develop the model. And anything that was tagged as testing was used for testing it after the fact. Now, to see this, if we go to our model performance overview, our preview, you'll see here, by the way, preview means beta. It's still being created by Microsoft, so it could be updated. But here's our job 1, and then here are our score results. So we talked about these scores in the PowerPoint version of the presentation. So in this case, I'm doing pretty good. My precision and recall for this model are pretty good. My F1 score, it's perfect in this case, 100%. So the model had enough data, and it was able to 100% accurately detect labels and label documents. So now, by the way, one important thing down here in the guidance section, it'll give you recommendations. So in this case here, it's saying I don't really have enough data labeled for training, so it's just recommending that I have at least 15 instances or things labeled. The more you label, the more accurate it's going to be. So take a look at this guidance information to help you with recommendations and so forth. Now that I'm happy with the results, if I weren't happy with the results, I would go back into my labeling, maybe add additional documents, maybe modify my labeling a little bit, rerun it, kick off another training job, and then look at the performance of the new training job. When I'm happy with it, then I deploy my model. So we're going to go in here, and we're going to add a deployment. And this essentially makes it production. So we're going to call this custom deploy. We'll just call it custom deploy. And then which model are we deploying? This one here, job one, the training model that we trained. And then where are we going to deploy to? So in this case, the same region where it's located. So we're going to click deploy here. This takes a couple seconds, and then it'll be deployed. So there you go. So now that it's deployed, here it is here, I can actually get a prediction URL for testing purposes. And if I'm using the Azure portal, I can actually put this in Azure CLI to do some testing with it if I need to also. So now I've got a production ready model. Now, instead of using command line to test it, we're just gonna, there's a separate section here under testing deployments where I can actually test the model myself. So I'm gonna go in here. I'm gonna use my custom deployment that I created, which is the model that I selected, that I built here. So we're gonna select that, and I'm gonna put in here the Yankees won by a score of 5-3. So let's put something like that. And we're going to run a test. So now, remember, the goal here is to identify in my training, in my data, I selected, articles, but it doesn't have to be articles. But I selected, all the sports articles I tagged as sports. So now I can go in and notice here I put the Yankees won by a score of 5-3, and I specified my model, did a test, and it came back and said, you know what? This would be tagged as sports. This would be labeled as sports, and then the confidence level of that. And if there's any additional information, you'll see that this is the JSON result version, which is normally how your code will pass it, but this is how we see it. So now that I've gone in and I've loaded the data, labeled the data, trained the model with the data, I've deployed the model, and I've tested it. Now I can use it in my actual application code. So let's take a look at it from a code perspective and how this would work. So I've got again, in our lab environment here, an application where it's going to called classify text. And I'm going to open up a integrated terminal for this just so we can get ready. But there's a couple of things I need to do in order to use my model. So number one, and whether you're using C# or if you're using Python and you're using a .env for your where's my .env? There we go. It doesn't matter. The process is the same. The code is a little bit different, but the concept and the process is still the same. So we're going to use C# here, and I'm going to go to appsettings.json, and notice here I need to put some connection information in here. So what this is looking for is it's looking for a couple key things here. So let's take a look at this here. So number one, I need my AI services endpoint. That is going to be in your Azure portal. And in this case here, we're using language and we're using custom text. So here is my endpoint. So we're going to put that endpoint here. So there's my endpoint. I also need a key, so I can use one of my two keys. So let's use this key here. So we'll use that key in our example here. And then the project and deployment IDs. So that's going to be provided by the Language Studio. So the project, there's a couple different ways you can find the project. So number one, if you just click on projects, there it is right there, demo custom text. Another way, if you're actually in the project itself, you can see it because it'll be right up here. Right there, demo custom text. So, and it's also right there. So I need to put that, this is all going to be case sensitive. So demo custom ext. Hopefully I typed that right. By the way, if you don't type it right, you'll know because when you try to run it, you'll get an error. And then it's asking for my deployment. So down here, here's my deployment. So my deployment would be custom deploy. So custom deploy, and notice here I forgot the T, And what I'll do is after we run this successfully, I'll go in here and change it so you can see the type of errors that you may get. So we've got that in there. So what we're going to do now is let's go back in here. Let's save this. So now I've got my app settings configured. So if I go to my program.cs where my code is, we're using AI text analytics for this. Now, what this application is going to do is it's going to generate a wrapper. And in that wrapper, it's going to include my Azure credentials, specifically the endpoint, which is right here. It's going to use my endpoint, and it's going to use the key for this to generate it right here, my key. And that key is right here. So think of that as like almost authentication, username and password. It's not, but think of it as something similar. So it's going to wrap it in there, which you can see right here. And then what's going to happen is this application is going to read some files from a folder. So it's going to read files, and here's the path for that file. And that file is actually here in the articles section here. And I've got two test files, test 1 and test 2. So it's going to read those files, and it's going to generate labels for them. It's going to automatically identify how they should be labeled. So let's go ahead and save our stuff here. And I've got the terminal open. So we're going to do a .NET run. It's going to process it here. There you go. So now here's what it did. So let's take a look at the first article, test 1. So notice here, test 1, celebrities come out for the big award ceremony. The stars of, so this is entertainment. So if you notice here, when the model looked at the test 1 file, it came back and tagged it as being entertainment, or flagged it as labeled as entertainment, which is accurate. Number 2, test 2. The league best, worst, Manchester United. So this is a soccer article here. So if you look here for text article for number 2, it comes back as sports, which is soccer. So this is how you can, and keep in mind, what we're demonstrating here is how to develop the resource and build your model and train your model, and then use it within a very simple application. In this case, just a console app. In the real world, you may start, I'll give you an example. Let's say you're a bank. You may want a system to go out and scan all of your folders and automatically tag every document that deals with loan applications, tag that, which means your model must be trained to look for loan application files. You may have another tag for credit score information, like a separate document for that. And you would have to train the model with that so it can identify those. You may have another documentation like an approval letter or a denial letter and so forth. So you can have all these files, train the model with a sampling of each one, and then point your AI instance, or in this case, your application, to the location of those files, and the model will automatically start analyzing and detecting and giving you a score. And then based off of that, let's say it's a category of, let's say it's an application that deals with banks. So it's a file for bank loans. I may want the bank loan data to be automatically moved to a different location and then, secure it. So I'd have a separate application or process that would move those files. So that's an example of where you could use this type of technology. So hopefully you enjoyed this demonstration here, and hopefully you'll come back for our next discussion and demonstration. Thank you.